Hey folks, welcome to the NCEA Level 2 Calculus paper from 2024. Joining us for the first time, the way this video works is I go through each answer and let you know what you need to do for achieved merit and excellence. The best way to watch this video is to pause the video at the start of each question, try the question out by yourselves, and then unpause the video just to see how I go about answering the question. So without further ado, let's get started. Alright folks, so for question 1a, what we've got is we've been given a function and we've been asked to find the gradient of this graph where x is equal to 2. So the first step we're going to do is we're going to differentiate the function. So when we differentiate the function, we are going to get 4x cubed is going to become 12x squared minus 6x squared will become 12x, and of course 5x will differentiate to 5. Once this is done, we are going to find the gradient at 2. So we're going to get 12 times 2 squared minus 12 times 2 plus 5. And putting this in the calculator, we've got 12 times 2 squared. That's going to be 4 minus 24 plus 5. And we should get an answer of 29. And once you put the answer down, you have to actually show that you get the derivative. So you have to actually show this line here, and then you actually have to give the answer as well. Now, there is a way to check this on the calculator. So you could actually go into, where is it? Click on option, go to calc, and notice how it says d of dx. So you can actually put that, and you could write your equation down, which is 4x cubed minus 6x squared plus, oh, sorry, it went too far, plus 5x plus 2. And our x value is equal to 2. And as you can see, you get the answer of 29 there. That's just a quick way to check it. But you have to show the differentiated function. So that's that first line there. Cool. Question B. So with question B, what we've got is this f dash of x. Graph is actually passing through 236, so that means f of 2 equals to 36. So we're going to take f dash of x first. So we've got 12 minus 4x plus 6x squared. We're going to find f of x. So 12, and that's just going to have x in front, minus 4x. Remember that x has a power of 1. So the 1 plus 1 is equal to 2, and that's divided by the new power, which is 2, plus 6x, and then we've got 2 plus 1 is 3, divided by the new power, which is 3, and don't forget the plus c. So we're going to simplify this. So we're going to get 12x minus 2x squared plus 2x cubed plus c. Now, correct antiderivative with plus c is going to get you an achieved. So getting up to here is going to get you an achieved, but we actually want to find the function. So we've got f of 2 is equal to 36. And because of that, we're going to go 36 is equal to 12 times 2 minus 2 times 2 squared plus 2 times 2 cubed plus c. So we're going to get 36 is equal to, let me just do that. So we got 24 minus 4 times 2 is 8, plus 8 times 2 is 16, and that's going to give me 32 plus c. So we can say c is equal to positive 4. So then our f of x is equal to 2x cubed minus 2x squared plus 12x plus 4. And getting up to here is going to get you a merit grade. And the answer schedule does say that, I mean, as long as you can write down c is equal to 4, it does say you don't need to rewrite the whole function. It just needs line 1, which is the integrated function, and then c is equal to 4 part as well. I'm surprised this question's worth a merit. Okay, question C. We have blah, 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 curve is given by this, use calculus methods to find coordinates of the local minimum, and then explain how you know it's a minimum point. All right, so we're going to differentiate the function first. So f dash of x is going to be 3x cubed will differentiate to 9x squared minus 9x squared will differentiate to 18x. Negative 27x is going to differentiate to negative 27. So this happens to be our differentiated function. Now we need to put this equal to 0 to find out where our turning points are. So we're going to go 9x squared minus 18x minus 27 equals to 0. And we are going to take the common factor of 9 out, which is 9x squared minus 2x minus 3 is equal to 0. 0 divided by 9 is just 0. So I've got x squared minus 2x minus 3 is equal to 0. And I can factorize this as x minus 3. X plus 1 equals to 0. Therefore, just do one extra step here. X minus 3 is equal to 0. And x plus 1 equals to 0. So x equals to 3 and x equals to minus 1. So this is part 1 here, and find the x coordinate of the local minimum. And I guess it's kind of like I've got to do both of these questions, both of these parts together, because to find whether something is a minimum or a maximum, I actually prefer using the double derivative formula, which is in the level 2 calculus playlist. So I think it's level 2 calculus in 10 hours playlist. I do talk quite a bit about the second derivative test, and that's definitely a lot easier to do, and it's much more cleaner, I believe, anyway. So what we're going to do is, for part 2, we are actually going to take f double dash of x. So when we do f double dash of x, we're going to get 18x minus 18, because all I'm doing is I am actually differentiating f dash of x from there. So 9x squared will become 18x. Minus 18x will become negative 18. Once this is done, what I need to do is I need to substitute 3 and negative 1. So when I substitute f double dash of 3, I'm going to get 18 times 3 minus 18, which is equal to positive 36. And because f double dash of 3 is positive, we can say that therefore this is minimum. Because if we take f double dash of negative 1, we're going to get 18 times negative 1 minus 18, which equals to negative 36. And because f double dash of negative 1 is negative, this is maximum. So we can say, therefore, x equals to 3 is the local minimum. Now, grades wise for this question, correct derivative founder and set 0 or implied is going to get you an achieved. So we're looking at this line here for achieved. X coordinates found is a merit. So this and this is going to get you a merit. And then it says x equals to 3 stated as the minimum, which we've done, and justifies why using second derivative test or graph of function or gradients. Now we've done second derivative, so that is going to equal an excellence grade for that question. All right, let's go to the next question. So with this question, what we've got is new line. So they need to minimize the surface area, which includes the lid. Okay, they want it to hold 500 mils. Okay, so what we kind of have is if you look at the volume is actually stationary, right? Because volume is equal to 500 mils. But we need to actually differentiate the surface area. Now the problem with differentiating surface area is, if you look at it, surface area has R, but it also has this H. Now whenever you differentiate something, you want to have the same letters. You cannot have two different letters in there. But what we do know is, we do know that the volume has to be 500 mils, which is there. And also, we've got H there, and we've also got the radius there. Now, here's where something that you need to know from the past is, one of the things that you need to be aware of is that 500 mils is the same thing as saying 500 centimeter cubed. And that's just something that, you would have done it in either level 1 or possibly sometimes in year 10 as well. So based on that, we're going to rewrite the volume equation as 500 equals pi r squared h. Now, I want to be able to differentiate the surface area. 2 pi r squared plus 2 pi RH. Now, as I said to you before, the problem is I've got an H there. I need to get rid of this H. But the way I could get rid of this H is I go back to the volume equation and notice that there's a H on this side. So what I'm going to do is I'm going to rewrite this as 500 divided by pi r squared equals H. Because when I do this, now all I've said is that H is equal to pi r squared. H equals to 500 divided by pi r squared. So if I go back to the surface area, I can write this as 2 pi squared plus 2 pi r multiplied by 500 divided by pi r squared, because this is H. Once that's done, I can then start simplifying things here. So I'm going to get 2 pi r squared plus, now 500 times 2 is going to become 1000. The pi's are going to cancel out, and the r and r1 is going to cancel out. So it's going to be 1000 over r. And I think this is where there was a bit of controversy in this paper last year, because how do you differentiate when r is in the denominator? Now, and I think this is why I feel like this question was at an excellence level, because people are arguing that this is stuff that you don't learn until year 13, but the ideas are already there, and if I explain it, you guys will understand it and you'll be like, oh yeah, it makes sense now. And I think that's the mark of a good excellence question, right? It just makes you think just that little bit extra. So anyway, we're going to go surface area equals to 2 pi squared plus. Now, you can't differentiate when a variable is in the denominator, so you have to bring it to the numerator. And the way I'm going to bring it to the numerator is by replacing that 1 with -1. Because remember that when you bring, in algebra, we used to do this like when there's something in the denominator and you bring it to the numerator, you change the power of that particular value with a negative or positive, right? So whatever the opposite of it is. So this is what it is. And then now I can differentiate surface area with respect to r, which means pi is a number. So I've got 2 times 2, which will become 4 pi r. And then on this side, I'm going to get minus 1000 r to the power of -1. Of course, I've got to take -1 of that. And what I'm ending up with is surface area is equal to 4 pi r minus 1000 r to the power of -2, which means I'm going to get 4 pi r minus 1000. R to the power of -2 could be written as r squared. And at this point, I kind of need to mention that if I want to find minimum, I need to put the differentiation function equals to 0. So I'm going to get 0 is equal to 4 pi r minus 1000 over r squared. Rearranging this, I'm going to get 1000 over r squared equals 4 pi r. Because notice how it's negative, but and I bring it over to the other side, it becomes positive. So I'm going to cross multiply the r squared. So I'm going to get 1000 equals 4 pi r times r squared. Running out of room here. So I'm going to get 1000 equals 4 pi r cubed. Get rid of the 4 pi to the other side. So I'm going to get 1000 divided by 4 pi equals r cubed. So then r is equal to the cube root of 1000 over 4 pi. So I'm going to go 3. No, actually, I'm not going to go 3. Shift that. So that's going to be 3. And then here, I'm going to have a fraction, 1000 divided by 4 pi. And that's going to give me a radius of 4.30. And I think the question is asking for the dimensions of the cylinder. So we've given the radius. Now we need to figure out what the height is. So the height is going to be 500 divided by pi squared. So the height is going to be 500 divided by pi times 4.30 squared. So I've got another fraction here, 500 divided by pi times, let's go, pi times answer squared. And that's going to give me a height of 8.60 centimeters. I guess the tricky part, I think people kind of find it challenging, was this right here. And I think once you got that stuff once you made the connection in the blue box, you were well and truly off. So grades wise, set up area equation in terms of one variable and differentiates. So we're looking at possibly setting it up in one variable and differentiates. Wow, that's tough. That's tough. But and differentiate. So I guess you're going to have to do it up to here to get it achieved. Make the surface area equal to 0 and finds R is a merit. Find both dimensions is an excellence. And folks, that's basically question 1. All right, folks, so for question 2, we've been asked to draw the different gradient function. And I think this is something that I actually enjoy doing, because all you really have to do is look at the turning points. So in this one, the first turning point is quite obvious, because I'm just going to kind of match it up here, right? So what I do is I basically just draw the lines directly underneath it, wherever the turning points are. Once that's done, then I know that this is a negative cubic. When I differentiate it, I'm going to get negative 3x squared, which means I should get a parabola that's going to be upside down. But it has to go through these 2 points, because those 2 points are where the gradient is equal to 0. So as long as this shape goes through this point and this point, you're pretty much good to go. And it's really interesting. I'm surprised that this question is actually worth a merit. Yeah, you heard it right. It's actually worth a merit. So both intercepts and shape correct is actually worth a merit. For achieved, you either have the shape correct or you got the intercepts but the wrong shape. That's a gimme for achieved. It's ridiculous, but anyway. Going on to question number 2. Merit. I cannot believe that the previous question was a merit, actually. All right, so we've got find the equation of the tangent of the graph at the point -2, 3. So we've got f of -2 equals to 3. To find the equation of the tangent, we need to figure out what the gradient at -2 is. So first we work out what the gradient function is. So we've got 3, which differentiates to 0, -12x differentiates to -12, and 3x cubed differentiates to 9x squared. So when we work out the gradient at -2, we're going to get -12 plus 9 times -2 squared. So we've got -12 plus 36. That's going to be 24. Now we need the equation of a straight line. So we got y minus y1 equals m times x minus x1. Remember that your y1 value is 3, your x1 value is -2, and your gradient is actually 24. With that in mind, we have y minus 3 equals 24 times x minus -2. So we're going to get y minus 3 equals 24 times x plus 2. Expanding the brackets, we're going to get 24x plus 48. And then y is equal to 24x plus 48 plus 3. And that's going to give us y is equal to 24x plus 51. Grades wise, correct derivative found is worth an achieved. And correct equation found is going to be a merit. Okay, next question. So pause the question and have a read through, folks. Okay, basically the part 1 of this question is asking, what is the rate at which the population is decreasing on day 10? Now remember, t is the day. So we're going to find p dash of 10 because that's what the question is actually asking. So find out p dash of t first. T cubed goes to 3t squared. Minus 60t squared will become minus 120t plus 768. The number 40,960 disappears. I don't have to worry about it. So we got p dash of 10 equals 3 times 10 squared minus 120 times 10 plus 768. So putting this in the calculator, going to get 3 times 100 minus 120, 10 plus 768. So we're actually getting minus 132. Basically, that just means that 132 bacteria per day is dying on day 10. All right. Now, grades-wise, this is actually worth and achieved. And then we shall go to the second part of this question. Now, for this question here, what it's asking is it's asking for the difference of population change. So now, if we go back to the original equation, so I'm looking at the equation right here. This is a positive t cubed, so it's a positive cubic. So if you think about the graph, because it's a positive cubic, the graph is going to look something like this. And there is a point when it hits maximum. And I think that's what they talk about here. Where is it? Population will be at maximum, and then it'll begin to decrease. So that's because they've used up all the nutrients. And then they say when the microbiologists add more nutrients, the population of bacteria will begin to increase again. So you notice how there's the yellow part of the word problem and the green part. So when it's actually decreasing, it's up to here. And then when they add more nutrients, it starts increasing again. Now we want to know the difference of the population size from this point to this point here when it actually starts to increase. So we want to find out the two turning points, find out the population itself, and then subtract the populations to figure out what the change is. So going back to my equation, I do need that equation. So this is my population equation. Now I need to figure out what my two turning points are. So I do need my differentiated function, which was 3t squared minus 120t plus 768. So I need to figure out what my two turning points are. Now to figure out my two turning points, I'm going to put p dash of t is equal to 0. For this purpose, I am going to plug this straight into the calculator. Now, if you don't have a graphics calculator, then you do need to use the quadratic formula. But however, in this case, I'm going to go down to equation, click on polynomial, which is f2 degree 1. So I've got 3 minus 120 and 768. So when I do this, I actually get t is equal to 8 and 32. So this part here is 8 days. This part here is 32 days. So I need to figure out what the population was when it was 8 days, and then population when it was 32 days. And then I should be able to work out the difference between the population size. So I'm going to go to population of 8 first. So to do that, in my calculator, what have I got here? 8. So I'm going to go 8 to the power of 3 minus 60 times 8 times 8. So, just realized what I did. Minus 60 times 8 times 8 plus 768 times 8 plus 4960. So this is giving me 43,776. Then I need to figure out what population was on the 32 day. I wonder if I can just do this. 32. There we go. That's going to give me 36,684. So now I need to go 43,776 minus 36,684. That's going to give me a population difference of 7,092. I'm looking at the answer schedule. I think the answer schedule has actually got the population change incorrect because they've got 6,912 there. But anyway, so grades wise for this question, correct differential is set to 0 is worth and achieved. T equals to 8 and 32 found is a merit. Correct change in population is worth an excellence. Another interesting question. All right, so going to D. All right, folks, now this is a very interesting question because, like, you know, you normally would have done these types of area questions before, but what we have is area of a trapezium where the A value happens to be this part here, and then the B value happens to be this part, and then the H, which is the height of the trapezium, is going to be there. So what they want to know is what's the maximum area, I believe it is it? Come from the maximum area of the trapezium. So with that in mind, we are going to write down what A value is. Now remember that this is 8x minus x squared is the parabola's equation, right? So that means if we take this particular point, let me just do this blue point here, this is going to be x and y. So that's going to become, remember that y is equal to 8x minus x squared. And then this point here, which is I'm going to put in red, but the x value, if you look at it, it's actually equal to 2x. So then y is equal to 8 times 2x minus 2x squared. So we're going to get 16x minus 4x squared. So this value here is going to be 16x minus 4x squared. Now once we have that, what we then have is the A value, which is the yellow part. That's going to be straightforward because that's just 8x minus x squared. The B value, which is the green line, that's going to be 16x minus 4x squared. And then the H value, which is the height, that's just going to be x because we're going to go 2x minus x, and we're going to get x. So if we look at the area, we've got a half multiplied by A plus B times H. So we're going to get a half multiplied by 8x minus x squared plus 16x minus 4x squared multiplied by x. So eventually we're going to get x over 2 times 24x minus 5x squared. And when we expand the brackets, we're going to get A is equal to 24 divided by 2 is going to be 12. We're going to get 12x squared minus 5x cubed over 2. This is the formula for the area of the trapezium in terms of x. We now need to differentiate it. We're going to get 24x minus 15x squared over 2. We're going to put this equal to 0. So 0 is equal to 24x minus 15x squared over 2. Take out x as a common factor. I think just the x is fine. We're going to get 24 minus 15x over 2. So we've got x is equal to 0, and we've got 24 minus 15x over 2 equals to 0. Rearranging this, I'm going to get, what am I going to get? I'm going to take the 15x to the other side. So I'm going to get 15x over 2, cross multiply. 24 times 2 is 48, 15x, and then therefore x is equal to 48 divided by 15. So when I do x equals to 48 divided by 15, what am I going to get? That's going to give me x is equal to 3.2. But the question is actually asking us to find the maximum area. So because it's asking us to find the maximum area, we've got 12 times 3.2 squared minus 5 times 3.2 cubed over 2. Basically, I've taken this equation from there, which is the area equation. And I just need to now work it out. So 12 times 3.2 times 3.2 minus 5 times 3.2 to the power of 3 divided by 2. So that's going to give me a maximum area of 40.96. So grades wise, correct expression for the area, reasonable area equation that has been differentiated correctly is achieved. So I guess you could potentially get an achieved here even if you make a little mistake. Merit is area equation correct, differentiated and set equal to 0. So we're looking at here for merit. And then finally, excellence is maximum area calculated. All right, and that's basically question 2, folks. And kickstarting question 3, we've got a function, find the coordinates where the gradient is equal to 3. So we need to find x and y for this. So we've got h dash of x is equal to 0.5x minus 2, and the gradient is equal to 3. So we want to know what's the x value for gradient equals to 3. So we're going to put down 3 is equal to 0.5x minus 2. Rearranging it, I'm going to get 3 plus 2 is 0.5x. 5 equals 0.5x. And then x is equal to 5 divided by 0.5. X is equal to 10. If x equals to 10, I need to figure out h of 10, which is 0.25 times 10 squared minus 2 times 10 plus 4. So that's going to give me, what do I got? 0.25 is 25 minus 20 plus 4. So that's going to give me 9. So the coordinates is going to be 10 and 9. Incredibly, even though this question has got so much more work, it is only worth and achieved. All right, part 2 of this, well, not part 2, second part of this question. We got truck is waiting at a red traffic light. Traffic light turns green. Truck begins to accelerate at 0.64. So acceleration is 0.64 until it reaches its top speed at 25. So top speed of 25. Use calculus to find the distance the truck traveled until it reached its top speed. So what we know is if acceleration is 0.64, then the velocity is going to be 0.64 t plus c, because we just integrate it. Now it says that it's starting from, because it's when the traffic light turns green, the truck begins to accelerate. So that means it's actually at stop. So when t is equal to 0, velocity equals to 0. So we can say 0 is equal to 64 times 0, 0.64 times 0 plus c. So we can see that c is equal to 0. So then the velocity function is equal to 0.64 t. Now we need to figure out when it reaches its top speed. When? So that's the t. We're looking for the t, right? So top speed is reached when it was 25 was the top speed. So if I go 25 equals 0.64 t, then t is equal to 25 divided by 0.64, which gives me 39.0625 seconds. So this is when the, what do you call it? The maximum speed happens. But I need to actually figure out the distance, how much distance it's traveled. So I need to actually work out what the distance formula is. Now, if the velocity formula is 0.64 t, then the distance formula would be 0.64 t squared over 2 plus c. And once again, because it's starting at that traffic light, the initial distance is going to be 0. So we can say that t is equal to 0, s is equal to 0. So 0 equals 0.640 squared over 2 plus c, which means that's all going to be 0. So s of t equals 0.64 t squared over 2. Now all I need to do is I just need to work out the distance at 39.0625, which equals to 0.64 over 2 is just 0.32. I should have done that before. Times t squared, which is 39.0625 squared. So let's just go this squared multiplied by 0.32. So that's going to give me 488.3 meters. Incredibly, this question is only worth, well, actually, no, not incredibly. I shouldn't say that. It is only worth the merit. So achieved is time to reach max velocity found, which with evidence that c equals to 0. So this is going to be achieved right here. Distance traveled correctly with evidence of the second one equals to 0. So you do need to put that, you do need these parts here, people. The proof of why c is equal to 0 in like kind of like both situations. You do need to put that to get the full merit grade. Okay, so question C. Okay, so with this question, what it's been asked is find the equation for f of x which passed through 1, 0. So what I've been given here is the gradient function. I'm going to work out what the gradient function is because I can see that the run is 2 and the rise is 1, and it also goes through 0.1 when when f dash, the y-intercept is equal to 1, right? So this is going to be, I can write this equation, this straight line equation, as f dash of x equals 1 over 2x plus 1. So the gradient function f dash of x equals 0.5x plus 1. Now I need to figure out what the f of x is, which passes through 1, 0. So f of 1 is equal to 0. So I'm going to integrate f dash of x, which is going to give me f of x, which is 0.5x squared over 2 plus x plus c. Once I have that, then because f of 1 is equal to 0, I can put 0 is equal to 0.5, 1 squared over 2 plus 1 plus c. So 0 is equal to 0.5 over 2, which is 0.25, plus 1 plus c. So with this, I'm going to get 0 is equal to 1.25 plus c. Therefore, c is equal to negative 1.25. So then my f of x is equal to 0.5 x squared over 2 plus 1 minus, plus 1x minus 1.25. So this is my equation. Now what it says is draw the graph of f of x on the axis below, labeling the coordinates of any intercepts or stationary points. So the first thing I know that is it actually goes through 1, 0. That's for sure. The next thing is I kind of need to figure out what the other values are. Now looking at it, what can I do? I've got a turning point there, but I think I just need to put this on to figure out what my turning points are. So I'm going to go into quadratic, not turning points, the roots. Polynomial, degree 2. My a value is 0.25 because it's 0.5 divided by 2 is 0.25. Then I've got 1 and negative 1.25. So as you can see, when I do those two things, I get positive 1 and negative 5. So those are my roots. Now I know that the turning point is happening right. Sorry, I'm just gonna go through this. So that's like using line of symmetry. I know that the turning point is going to happen when x equals to 2. So what I'm going to do is go back here. I'm going to go 0.25 times 2 squared plus 2 minus 1.25. Oh, I forgot something there, haven't I? Yep, I know what the mistake is. It's negative 2, not positive 2. So 0.25 times negative 2 times negative 2 is going to be 4 minus 2 minus 1.25. There we go. That gives me negative 2.25. So negative 2.25 is somewhere there. Just because I've got labeling the coordinates of any intercepts or stationary points. I think these are the parts that I want. So I'm going to roughly draw my graph and put this as 1, 0. Put this as negative 5, 0. And the turning point here as negative 2, negative 2.25. Yep. And I've given everything that I need. Okay, so with this question, grades wise, you need any two of the positive quadratic shapes. Sorry, I think I'll just have to show you guys this. So here we go. So any two of this, so you can do a positive quadratic shape, or the roots, or correct x value for minimum, for an achieved, for a merit. You got correct function and graph drawn well, graph drawn well, but minimum not correct y value. And if you do everything correct, you should be looking at an excellence. So yeah, bit of a strange question. I don't think in all my years of doing calculus papers, I've seen a question like this, where they actually mark you for drawing the graph accurately, this accurately. I don't think I've seen it. But anyway, so yeah, so fully done, everything correct is going to be excellence. Merit is for correct function and graph drawn. So function, so these two things here, but wrong y value, like the minimum y value, then you can get a merit. Achieved is getting either the shape or the roots. There's, as I said, there's quite a few things that you can do for achieved. All right, let's go to the next question. Okay, so with next question, we've got y equals to k minus x. Use calculus to show that minimum value for x squared plus 2y squared equals to that. Okay, so if y is equal to k minus x, the maximum value, which I'm going to put it as our minimum value, which is v, I've got x squared plus 2y squared. And because y is equal to k minus x, I'm going to replace it with the y here, which means I should get x squared plus 2 k minus x squared. So v is equal to x squared plus 2 k minus x times k minus x. Expand the brackets using FOIL or whichever method you're comfortable with. You're going to get k squared minus 2xk plus x squared. So then v is equal to x squared plus, expand the brackets, 2k squared minus 4xk plus 2x squared. So this can be simplified as 3x squared plus, oh no, wait, let's go minus 4xk plus 2k squared. Now we want to actually figure out that this is for the minimum value, so we're going to differentiate it. So v dash is equal to 3x squared differentiates to 6x, minus 4xk differentiates to minus 4k, and 2k squared, well, there's no x attached to it, so that's just going to become 0. So to find minimum, v dash equals to 0 for minimum. So 0 is equal to 6x minus 4k. And if we rearrange this, we're going to get 6x equals to 4k. X is equal to 4k over 6, or x is equal to 2k over 3. Now, it says that the minimum value is equal to 2k squared over 3. So what we do need to do is we need to figure out what the y value is. And because y is equal to k minus x, we can say that y is equal to k minus 2k over 3. And I'm going to write this as with same denominators. So that's going to become 3k over 3 minus 2k over 3. And we're going to get y is equal to k over 3. So minimum value, which is x squared plus 2y squared. Now x is equal to 2k over 3 squared plus 2 times y is k over 3 squared. So expanding the brackets, 2k squared will become 4k squared, 3 squared will become 9, plus 2 times k squared over 3 squared equals to 9. Now this is equal to 6k squared over 9, which then simplifies to 2k squared over 3. And we pretty much proved that it's equal to 2k squared over 3. So grades wise, value equation found and differentiated is going to become achieved. So I guess this part right here is going to get you an achieved. Value for x or y found after setting v dash equal to 0. So up to here could get you a merit. Final proof is excellence. So I guess we might want to say that minimum value Cool, and that's basically question 3. All right, folks, that's basically it for this exam paper here. Made a few silly mistakes here and there myself. Had to go and re-edit some of that parts out. But as for you guys, just make sure that you don't actually leave any questions empty in the exam paper. And if you do have any questions or comments about this paper, feel free to put it up on the comment section. Good luck for your exams.
Hey guys, that is basically it for this video. As always, don't forget to like this video, share this video, and of course subscribe to keep up with the latest content. There should be some playlists popping up. Check them out. Great revision material. And as always, thank you for watching.